increases, resulting in lower penetration. A longer arc length increases the chances of the weld droplet as it is traveling across the arc cap, picking up contaminants from the atmosphere. A noisy crackling arc sound is the result of low voltage. With low voltage, the wire is driven into the weld, disturbing the puddle, causing spatter. The weld bead will be narrow and convex in shape. Smoke levels will be reduced as the voltage is decreased. Notice the decrease in bead width and resultant increase in spatter.
Let's have a look at a spray transfer.
A careful balance of wire feed and voltage must be maintained. With 045 wire, set the voltage at 27 to 28 volts. Put the wire feed at the 2 to 3 o'clock position, or 300 to 400 inches per minute. By following the simple parameters suggested in this video, clean, spatter-free welds can be achieved every time.
There's a lot of welding gases available on the market. Many instances, there's so many that there's a lot of confusion out there. When we look at a gas today, basically all the argon mixes fundamentally will do a good weld, a good quality weld. Therefore, what should we look for in selecting an argon mix?
With CO2, spray transfer is not possible. The large erratic droplets are caused by an upward repelling force in the CO2 plasma. The arc is always unstable, producing large amounts of spatter. When the CO2 is mixed with an inert gas such as an argon, the droplet transfer changes. 75% argon plus 25% CO2 still produces erratic, large droplets unless excessive currents and voltages are used. A typical argon mix would have 5 to 20% CO2 for spray transfer. 15 to 20% CO2, in contrast to other argon mixes, provides high arc energy across the width of the weld bead. Note the way the droplets are drawn into the weld puddle, adding to the penetration. 15 to 20% CO2 is an ideal mix for spray transfer on heavy plate over 1/2 inch, which requires optimum penetration with minimum porosity. On plate with poor surface conditions, such as rust or mill scale, CO2 in this range provides improved arc stability. As the CO2 content is reduced, weld droplet size decreases and falls axially. The narrow, stable arc produces central penetration. 5 to 12% CO2 is ideal on 1/8 to 3/8 inch clean plate. 2 to 5% oxygen added to argon produces weld droplet transfer similar to 5 to 12% CO2. The shorter arc length is a result of lower voltage requirements. Penetration is typically finger-shaped. 2 to 5% oxygen is ideal on 1/8 to 3/8 inch clean plate. Argon tri and quad mixes all produce stable droplet transfer, similar to argon oxygen mixes. As the reactive gases or helium content increases, the arc energy will increase proportionally. These mixes are typically used on 1/8 to 3/4 inch moderately clean plate.
This particular plant, or this style of plant, would do well to put its gas at about 15 to 16% CO2. Now it has a gas for short-circuiting. It also has a gas for spray on any application. It also has a mix which is very suitable for flux cord wires or position type wires. It has a good multi-purpose gas which will get the job done and provide all the energy required for the specific applications. What we've discussed in this training film is really understanding parameters. We don't have to remember the type of amperage for every thickness. We simply have to remember that if we're welding thin metals, that to simply put the wire feed around the 11 o'clock position, or if you have a digital wire feeder, set it up around 150 to 200 inches a minute. And remember to put the voltage for short arc at, well, 17, 18 volts. And if you're welding the very thin metals, then put the voltage at 16 volts. As we go into the thicker materials, we go into spray transfer. And with spray transfer, we simply put the voltage. Now we add another 10 volts to what we had when we were short-circuiting welding, so 27 volts. Put the wire feeder around about the 2 o'clock position. Or again, if you have a digital wire feeder, put it about 400 inches a minute. Then make slight adjustments on the arc. If you see spatter, it usually means the wire is driving into the weld. If you slightly increase your voltage, a gap will be created between the end of the wire and the weld, and we will have less spatter. So you can either slightly increase voltage or slightly reduce the amount of wire that's running into the weld. That's what spatter is. It's the wire running into the weld. We'd like to thank Fruhoff Trailer Company here in Canada for their cooperation in making this training film. And we hope it will be of some benefit to you. Thank you.